Hello students, in this video we want to take the correction for lesson 4 and 5 classwork, that is taking a division of surds and conjugate of binomial surd. So we'll take the correction for the classwork. Okay, lesson 4 and 5 classwork. You have the instruction: rationalize the following. Number 1, 15 over root 5. Number 2, 3 root 2 plus 2 root 3 over 4 root 2. Number 3, express 2 root 5 plus 5 root 2 over 2 root 5 minus 5 root 2 in the form q plus arrow root s. What it means is that your answer should be in this form. Not that you are going to solve the problem and have p and have q arrow s. A number will represent q, a number will represent arrow, a number will represent s. We were told that where q, arrow and s are rational numbers, that is, they can be number expressed in the form of a fraction, as you learned earlier. Number 4, simplify without using tables. Without using tables. Of course, to do this, you need to rationalize by taking the conjugate of the denominator to multiply both numerator and denominator. You can see that what we are doing here is not playing. These questions are past WAEC question. That tells you the seriousness of this online class. So take it more serious. Take it more serious. So let's take the solution to these problems. Number 1, when you are rationalizing a surd such that you have a single irrational number in the denominator, our aim is to change it to rational number, and to do that you use the irrational number to multiply both numerator and denominator in this form. That's all you do when you have a single irrational number in the denominator. So 15 times root 5 is 15 root 5. Root 5 times root 5 is root 25, and root 25 is 5. If you divide 15 by 5, you have 3 root 5 as the result of rationalizing that surd. For number 2, is the same procedure. This is a problem that you have. Though the denominator is 4 root 2, but the irrational number in it is root 2 that we need to remove or change it to rational number. To do that, you use root 2 to multiply the numerator and denominator. You use root 2 to multiply the numerator and denominator. You can see in this form. So here, when we are to expand, you use 3 root 2 to multiply root 2 and 2 root 3 to multiply root 2. Just a single number there. So 3 times, okay, here now we assume that there's a coefficient of 1 here. So 3 times 1 is 3. Root 2 times root 2 is root 4. And root 4 is 2. Then when we come here, 2 times 1, this 2 here times 1 is 2. Root 3 times root 2 is root 6, because different surds can be multiplied. In the denominator, you have coefficient of 1 attached to root 2. So 4 times 1 is 4. Root 2 times root 2 is root 4. And root 4 is 2. See that at this point now, we have changed the irrational number to a rational number. Number without a square root. So you multiply the numerator. 3 times 2, you have 6 plus 2 root 6. In the denominator, 4 times 2 is 8. You can stop here, but it is better you express your answer in simplest form. Looking at the whole problem, you can factor out 2 from the numerator because it can reduce 8. If you factor out 2, this is 2 now. The term you factor out, you use it to divide through the numerator. You divide 6 by 2, you have 3 left. You divide 2 root 6 by 2, you are left with root 6. By the time 2 and 8 are divided by 2, this 2 is gone. You are left with 3 plus root 6 all over 4 in the denominator. You have successfully changed the irrational number root 2 to a rational number 4. That is a process of rationalizing the denominator of a surd when you have a single surd in the denominator. Okay. Number 3, we call it a complex surd or a composite surd because the denominator is the difference of two surds. Remember, your answer must be in this first. I said before, Q, arrow, S. They should not be the answer, but they are rational number. But the answer should be expressed such that one number is Q, one is arrow, and the number and the irrational number is S. That is the meaning. Once you have a complex surd like this, what you do is to take the conjugate. And I told us earlier that conjugate is simply change in signs that connect the surd itself. So this is the denominator. The conjugate, this minus sign changes to plus. So you use this conjugate to multiply both numerator and denominator in order to rationalize it. Okay, so you have the problem here: the conjugate multiplying the numerator, the conjugate multiplying the denominator. You know the rule: first term times first term times second term. When you are done, second term times first term times second term. So you take 2 times 2, or 2 root 5 times 2 root 5, where you have 2 times 2 is 4. Root 5 times root 5 is root 25, and that is 5. Then 2 root 5 times 5 root 2, the second term, where you have 2 times 5, that is 10. Root 5 times root 2, that is root 10. Plus the second term, 5 root 2 times the first term, 2 root 5, that is 10 root 2, because 5 times 2 is 10. Root 2 times root 5 is root 10. Second term times the last term, 5 times 5, 25. Root 2 times root 2 is root 4, and root 4 is 2. For the denominator, you take 2 root 5 to multiply 2 root 5 and 5 root 2. So 2 root 5 times 2 root 5, that is 2 times 2, 4. Root 5 times root 5 is root 25, and that is 5. Then 2 root 5 times plus 5 root 2. 2 times 5 is 10. Root 5 times root 2 is root 10. You take the second term minus 5 root 2 to multiply all the terms in the second side. So minus 5 times 10 is minus 10. Root 2 times root 5, that is minus 10 root 10. The last term, that is 5, the second term rather, minus 5 root 2 times the last term here, minus 5 times plus 5 is minus 25. Root 2 times root 2 is root 4, and that is 2. So if you multiply the numerator, you have 20, that is 5 times 2, 20. 5 times 4, 5 times 4, 20. These two terms are alike. You can add similar sort. So 10 root 10 plus 10 root 10, that is 20 root 10. 25 times 2, you have 50. In the denominator, 4 times 5 is 20 plus 10 root 10 minus 10 root 10 is 0, followed by minus 25 times 2 is 50. If you add the constants in the numerator, you have 70 plus 20 root 10. If you subtract the denominator, you have minus 30. So for us to have this form now, so you need to break it down. You know the numerator, the two terms, the numerator, they share minus 30 in common. So you split it. Let each term take minus 30 in this form. You see what we are aiming at now, alright? So from here, 0 cancels 0. You have minus 3 over minus 7 over 3. This minus sign can be anywhere, precisely the middle of 7 and 3. Then plus against minus is minus. You cancel this 0 by 0. The irrational number 10, you cannot cancel that 0. It's only the constant, the term outside the square root sign. So you have 2 root 10 over 3. So from here you can say that Q is minus 7 root minus 7 over 3. Arrow is minus 2 over 3, while S is 10. So that is the meaning. Like I said, your answer, you don't have Q, arrow, S, but the way you will express the answer tells you what is Q, what is arrow, and what is S. Okay? Number 4, we are doing the same thing. This is a complex surd. To rationalize, you take the conjugate of the denominator, 6 plus 5 root 2, and the conjugate is 6 minus 5 root 2. 6 minus 5 root 2. So you take the conjugate to multiply numerator and denominator. So you have 5 multiply 6, that is 30. The same 5 multiply minus 5 root 2. So you have 5 times minus 5 now is 25. Then you have root 2. Then the second term, minus 3 root 2 multiply 6. Minus 3 times 6 is minus 18. Then you have root 2. The same term minus 3 root 2 multiply minus 5 root 2. Minus 3 times minus 5 is plus 15. Root 2 times root 2 is root 4, and root 4 is 2. For the denominator, you have 6 multiply everything here. So 6 times 6, 36. 6 times minus 5 root 2, that is minus 30 root 2. You use the second term 5 root 2 to multiply everything as well. So you have plus 5 root 2 times 6. You can multiply the constant. 5 times 6, that is 30, then root 2. Plus times minus is minus. 5 times 5, 25. Root 2 times root 2, that is root 4, and root 4 is 2. So here we have 30. These two terms, they are alike, they can be added. Minus 25 root 2 minus 18 root 2, that is minus 43 root 2, plus 5 times 15 times 2, that is 30. Okay, for the denominator, you have 36 minus 30 root 2 plus 30 root 2 is 0, followed by minus 50, that is 25 times 2. You can add 30 and 30 in the numerator, so you have 60 minus 43 root 2. If you subtract 36 minus 50, you have minus 14. You can also split it down, because 60 and minus 43 root 2, they have minus 14 in common. So you can let each term in the numerator have minus 14 in separate form. So if you divide 60 and 14 by 2, you have minus 30 over 7. Minus against minus is plus, so here is plus. There is no common term to 43 and 14. So this is your final answer. Since the second term, this term now is positive, and you know you can ignore positive, so you can decide to write it first, then this term that has negative comes second. If you leave your answer at this step, you are 100% correct. So this is the solution to the classwork of lesson 4 and 5. So mark for yourself correctly after submitting your classwork, and you take the correction. For updates, follow Peter Course Educom via YouTube at Peter Course Simplified Maths. To do that, subscribe to this channel, like the video, share it to your friends, your colleagues, your classmates. You can also follow us on Facebook at fb.me/PeterCourseEducom. You can follow us on Instagram at PeterCourseEC. You can follow us on Telegram t.me/PeterCourseEducom, and on WhatsApp through this mobile telephone number. All right, take good care of yourself, stay out of trouble, and have a wonderful day ahead. Goodbye, students.